This is exercise 5.2 from the textbook. I have got my formulas here, so need to be able to use those all the way through. So we have three identical resistors of 3 ohms are connected in parallel in a circuit. The effective resistance would be. So we've basically got this situation. So you've got 3 resistors that are in parallel like that. Each of these are 3 ohms. So what effectively happens here is that if you've got a current coming in like this, the current can actually divide into 3 different paths. So by having the 3 resistors in parallel, it provides an extra place or extra thicker wire for the current to go through, and therefore you're going to see that it reduces the resistance. But let's put it into our formula. Because we're dealing with resistance in parallel, we're going to be using that formula over there. So 1 over R total is 1 over R3, 1 over 3. So a third plus a third plus a third is 1. So it's 1 over RT. So RT is equal to 1 ohm. So effectively what we could do is put in a 1 ohm resistor here, and that will give the same effect as those 3 ohm resistors. I think you can also see that because you've got 3 ohm resistors in parallel, you're reducing the resistance in each case. So because you're making it 3 different paths, you're actually cutting the resistance by 3. So obviously A would be the correct answer. In a television tube, the picture is produced in a fluorescent material in the front of the picture tube by, it's actually going to be D, a stream of electrons. We don't really use television tubes much anymore. Most use now flat screen televisions, but in the older times they used to use that. Question 3. A 100-watt light globe gives out a brighter light than a 60-watt globe, mainly because. Now, just to understand this, let's just talk about it. When you've got 100 watt, that means that it's 100 joules per second. So it's using 100 joules of electrical energy per second, which is transferred into heat and light. Obviously, the 60 watt is 60 joules per second. So this is the energy that each is using per second. Now, in a 100 watt, 60 watt, we're talking generally in a household situation or in a business situation, and there usually the voltage is set at either 240, 220. If you're in the United States, it would be 110. So that is constant. What actually changes is the current, because if we look at this formula over here, P is equal to V times I. If this is 100, that's equal to 240 times your I for that one. And if it's 60, it's 240 times, 240 times by I also. So obviously if this is 1 and this is 2, this I2 needs to be less. So this 100 watt will draw a larger current. And with it drawing a larger current, it therefore is obviously transferring more energy to the electric bulb, and therefore causing more light and heat. Okay, so C would be correct there. Okay. Alright, so here's question 4. Sorry about the break there. I was just getting it in place. In a circuit below, a heater with a resistance R, it's a heater, is connected in series with a 48 supply and a resistor S. If the potential difference across the heater is maintained at 12 volts, so we've got this heater over here is 12 volts across there, and the resistance of S should be. So we have here that we're going to have to do it in terms of R. Obviously here we are going to have across this one, if that's 12, this will be 36 volts. Now the same current is going to be going right the way through the circuit, so your I will be the same. So if R is equal to V over I, then if you've got R, if this is R over here, that would equal 12 over I, and your S, your resistance for this one over here, would equal 36 over I. So obviously this is going to be 3 times that. So we're going to have the resistor S will be 3R, 3 times the resistance there for that one. So it's question 4, it would be D. So going on to the next one now. Question 5. It says the diagram below shows circuits X, Y, and Z of 3 resistors, each resistor having the same resistance. Which one of the following shows the resistance of the circuit in increasing order of magnitude? Now, I think there should be a resistor in there like that. So let's do it here. Let's put in a value. Let's say each of these is 2 ohms. So let's work out the resistance in each of these. 2 ohms, 2 ohms, 2 ohms, and 2 ohms, 2 ohms, and 2 ohms. Alright, so for X, this over here, to work out the resistance of that, is going to be 1 over RT is equal to 1 over 2 plus 1 over 2. That's obviously going to equal 1 ohm is RT. So we can see that it's 2 different ways, so obviously your resistance is halved. So you can replace that one there, you can replace this one by a 1 ohm resistor. So your effective resistance for this would actually be 3 ohms, the 2 ohms plus the 1 ohm, according to this formula over here for resistance in series. For here, these are all in parallel, so we're going to get 1 over RT equals 1 over 2 plus 1 over 2 plus 1 over 2, which is going to equal 3 over 2. This is 1 over RT. You've got 3 halves, and then you're going to invert both sides, so it's going to be RT is equal to 2 over 3 ohms. So this one over here will be 2 over 3 ohms, or 0.66 ohms. For this one over here, for circuit Z, you've got an effective resistance in this branch here of 4 ohms. 4 ohms there. And so your resistance for here would be 1 over RT would equal 1 over 4 plus 1 over 2. So that's going to be 4, this will be 1 plus, that's going to be 2, so it's going to be 3/4. 1 over RT will equal 3/4. So your RT will equal 4 over 3, which is equal to 1 1/3 ohms. So you're going to get 1 1/3, 1 1/3 ohms there. So looking at it from lowest is going to be circuit Y. So we've got that one over there. Next one is Z, and the next one is X. So it is going to be A will be the correct one for that one. Here we've got a question for question 6, and the answers are over the page. I'm going to just discuss it just using the diagram. The graph below shows the current voltage characteristic of a filament lamp, and the question is the resistance of the filament at 3 volts is. Now, so we're looking for the resistance at 3 volts. So we're looking at that situation over there. Now, your resistance is defined as your ratio of the voltage over your current. it's that specific value at that time. So you don't find the slope of it. It's that ratio of V over I in each case. So what we've got to do is we've got to see what is our current. And so we got our R is equal to 3 over our I. This obviously is going to be 12. Each of these, 12, 13, 14, 15. Let's just see how much this is. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So halfway through would be 12. So we're looking at about 13 there. Somewhere about 13. So let's have a look at the answers. The answers that you could possibly get there. We get 3 divided by 13. We're going to get about 3 divided by 12. The only answer that's anywhere near correct is A, 0.25. 3 divided by 12. So R is about 0.25 ohms.